Hi everyone, in this video we will start with graphing rational functions, and the first concept we will understand in this topic will be vertical and horizontal asymptotes of rational function, right? Okay, so if you have a rational function that will be like f of x is equal a of x over b of x. This is your rational function when a of x and b of x are polynomial functions. Okay, polynomial functions mean something like if you have x square plus 2x plus 3 x power 3 plus 6x plus 4, like this. Okay, 4x plus 4, if you have something like this. So these are the polynomial functions where these two functions should have no common factor. Okay, a of x and b of x should have no common factor other than 1. Okay, so basically there is no common factor, and b of x should not be equal to 0, because if this is 0 the function will be undefined. If b of x is 0 then function is undefined. I've discussed these kind of things in the previous videos. You can watch the reciprocal functions to understand about all that. Okay, now the important part here is if the first point is if you have function f of x equal a of x over b of x, there are key points that you need to remember. First, f of x will have a vertical asymptote. Where will be the vertical asymptote? Where b of x is equal 0. What do I mean? For example, if b of x is 6x plus 1, then if it is equal to 0, what you will get? X equal negative 1 over 6. So what will be your vertical asymptote? X equal negative 1 over 6. So that's how you will find the vertical asymptote, by keeping this equal 0, right? In all the rational function. Now how you will find the horizontal asymptote? For the horizontal asymptote we have some conditions, or yes. So first one we have, if if a of x, the degree of a of x, okay, the degree of a of x, the polynomial here, is more than or greater than the degree of b of x. Okay, what do I mean? If your function look like, for example, f of x is equal x square over x plus 1, here now this degree is more than the degree of b of x, then there will be no horizontal asymptote. No horizontal asymptote, right? So now you will be able to find out for the functions where if f of in the f of x, if a of x has the highest degree, then there will be no horizontal asymptote. So let me draw the table here. If a of x degree is more than the degree of b of x, then there is no horizontal asymptote. Condition 1. If the degree of a of x is less than degree of b of x, then there will be horizontal asymptote at y equals 0. At line y equals 0, there will be horizontal asymptote. But if you have the degree of a of x is equal degree of b of x, then your horizontal asymptote will be leading coefficient of a of x divided with leading coefficient of b of x. What does it mean? If you have a function, for example, 2x plus 1 divide 3x minus 1. Now in this case the degree is same, right? This degree of a of x is 1, degree of b of x is also 1. Now the leading coefficient is 2 here, so 2 divide leading coefficient here is 3. So your horizontal asymptote is 2 over 3. Okay, And when I said degree of a of x is less than b of x, this will take an example, for example 4 divide x square plus 1. So there is a of x is only a constant. Now here there is a degree 0, here the degree is 2. So as you can see, the b of x degree is more than a of x, right? Okay, so that's how you will find the horizontal and vertical asymptote of a rational function. Now what will be the graph look like? So let's try to understand using some example. Okay, now first example we have, if your function is f of x equal x square over x plus 1. Now what will be your vertical asymptote? Vertical asymptote is x equal minus 1. Horizontal asymptote, for the horizontal asymptote you need to check degree of a of x is 2, degree of b of x is 1. So this is more than 1, so there will be no horizontal asymptote, right? Now how you will graph it? So vertical asymptote is at x equal minus 1, so there is minus 1 somewhere, right? Yes. Okay, now, yep, so this will somewhere look like, is there any 0 also? Yeah, you need to check that also. To check the zeros, you will keep the numerator equal 0. So if you put x square is equal 0, you can find x equal 0, because if you solve this, the zeros are at x equals 0, so the graph will touch at x equals 0. Okay, so this will look like something touching at x equals 0 at this point. So and somewhere like this, this is a rough graph, so you can check in the Desmos. Okay, that's how it will look like. Okay, now next one is, if you have f of x is equal, let's say 3 over x square minus 1. Now in this case, again vertical asymptote is minus 1 and plus 1. Why? Because this x square minus 1 will be factored into x plus 1 and x minus 1. Use the zero product property, you will get minus 1 and plus 1. Okay, that's the formula a square minus b square. Okay, now what is your horizontal asymptote? Now if you see, the degree of this is 0, this is 2, so b of x degree is more than this, so horizontal asymptote will be uh, y equals 0, or you can say in this case f of x equals 0, right? That will be your horizontal asymptote. So now let's try to draw the graph. So horizontal asymptote is at x equals 0, so there will be no change here. Vertical asymptote is at negative 1 and positive 1, so these will be your vertical asymptote. Okay, now the graph will look like something like this. So you don't have to worry about the graph here. Okay, but the main concept is the horizontal and vertical asymptote. So if you are able to draw them, then use the Desmos to see how the graph will look like. Okay, because in this topic I'm not going to explain how the graphing will work, but you can try with the Desmos. Okay, or else the video will be too long. Okay, next one is, if you have f of x is equal 2x plus 1 over x minus 3. Now what is the vertical asymptote? Again, vertical asymptote is 3. What will be your horizontal asymptote? In this case the degree is 1, degree is 1, so same. Now the degree is 1 and this is 1, so leading coefficient of this and leading coefficient is this, so 2 over 1 will be 2. Vertical asymptote, horizontal asymptote. Now let's try to graph the asymptotes on this axis, the coordinate plane. This is your x, this is your f of x. Now horizontal asymptote is at 2, so 2 will be somewhere here. Vertical asymptote is 3, so that will be somewhere in the positive side of x. That's it. If you are able to draw this, then you are good. Okay. Now what will be the graph look like? The graph will look like something like this. You can check with the Desmos, as I said again. Okay, now that doesn't matter if you draw the vertical asymptote first or horizontal asymptote first, but this is how the graph will look like. So that's it for the video. Let me write some questions for you so you can try them by yourself. Okay, and let's say the question number 1 is f of x is equal x square minus x minus 6 divide x minus 1. So you have to find the vertical asymptote, horizontal asymptote, and try to graph the function. Okay, to graph the function, what you can do is you can use in the calculator, press mode, then press table, and in the table take domain, range, and step. So domain you can decide other than vertical asymptote, horizontal asymptote, right? Or else you can just simply decide the steps from the length from let's say -10 to +10. Okay, or else just fill there. The range is actually the length for x-axis from -10 to +10. Similarly, do that for the range, for the domain and then range, and take the step as 1. So what you will get x values and f of x values. If you haven't done this, then probably you will not understand, but if you have a calculator like this, then try with that. Or else try the vertical asymptote, horizontal asymptote, and we will discuss the graphing in the next part of the video. Okay, basically what you have to do is you just have to put the value of x from some point, let's say -5, -4, -3, -2, -1, 0, and you will have to find values of f of x, and then you have to try graphing the function. That's how it works. So that will be a longer method. Okay, so that's it for the video, and I hope you understood, and please watch the video once again if there is any doubt. That's it.